Hello Algebra, and welcome to our next video, and it is graphing contextual problems. And that word contextual, so there's context in the front of it, and it just means using real life situations, so in context. So we're going to get a chance today to practice not only some more systems, so it says right here I can use systems, but also some of those word problem skills that we were so amazing at. So we're going to dive right into an example of what a systems question presented as a word problem will look like. So it says, Swifty and Nicki Minaj are about to record an album together. They have a choice between two recording studios. Now, you have to suspend belief in that it would be this simple, but we've just made this up. One studio charges a $50 flat fee plus $2 per minute. The second charges a $20 flat fee plus $4 a minute. Taylor thinks they should go with the second studio. Nicki Minaj thinks they should go with the first. For what numbers of minutes would each studio make sense? Use equations in a graph to justify your response. So that question there, for what numbers of minutes would each studio make sense? That's kind of what they're asking for here. And what that means is, at a certain point, one will make sense more than the other one. For a certain amount of minutes, one will be more expensive. For another amount of minutes, another one will be more expensive. And we're going to use systems to visually show when it's better to use which one. But first, we need equations. We can't just graph based on feeling. So the two lines are going to be the two studios. Here's the first one. One studio charges a $50 flat fee plus $2 per minute. Well, a flat fee is something that never changes, or otherwise known as a constant. So no matter how long they're in there, they're going to pay that $50. But then there's a certain rate. There's a slope, shall we say, of $2 per 1 minute. So that's $2 per 1 minute. You don't really need the 1, but it helps to show that. So if we're going to say how much it costs, they're both positive. They're both something you pay. So we'd say y equals 2x plus 50. Now, I've just used variables x and y. I didn't say what they meant, though, and it's probably good to say what they mean. So we'll say y is going to represent the total cost of the studio. And then x, since I attached it to the 2, and I said 2 per minute, that's going to be the number of minutes. Number of minutes at the studio. So I got my first one. Here's studio number 1. For studio 2, I use a different color here. It is a $20 flat fee, so it's less up front, and $4 a minute. I think these studios are for people who only were going to record for like an hour. Alright, so we got to graph these now. So I'm holding my orange marker, so let's use that first. I look over at my graph, and I don't have a scale yet. Well, I'm going to start both of them in the y-intercepts of 20 and 50. So it might not make sense to start at 0 and go by 1s, because I wouldn't even be able to fit 50 on here. So we have to think about our scale here. I think it might make sense to go by 5s. We can decide later if that makes any sense, but we can always change it. So if I do every 5, or every one is worth 5, it'll start to look like that. But I don't want to write every single one of those. I'm going to skip. Do 20, 30. I'm going to pause the video and fill this out. Alright, I got my scale, and I want to start the orange one, or Studio 2, at 20. Because no matter what, we're paying that, even if we walk in and walk back out. And then it goes up $4 for every 1 minute. Oh, and I didn't label here. This is minutes, and this is cost. So, let's see. The problem is going to be if I go up 4, that doesn't really graph well, because every line is worth 5. So maybe I want a multiple. But also, when I go to the right, I go 5. So if I go right one notch, meaning like to the right one, I'm actually going 5 minutes. And since it's $4 every 5 minutes, I'm really going $20 every 5 minutes. So what I want to do is go up like this. So this one goes up quite fast. For every 5 minutes, I go up another $20. Every 5 minutes, up $20. So this might be too steep. We might have to adjust if our lines don't end up meeting. And then the green one, this one starts at 50. But we go we'll say every 5 minutes it goes up 10, right? That makes sense? Every 5 minutes it goes up 10. So this one's less steep, so it'll meet somewhere. I think we're okay. Every 5 minutes it goes up 10. And they meet right here. So again, I didn't give myself a whole lot of room. There's probably a better way to do this if you spread out your time a little bit more than I did. In fact, I'm going to show that. We're going to adjust our scale at the bottom and maybe go just every 2 minutes. This is something you have to do once you're something like that. So you kind of have to do a little trial and error sometimes. What is that? 1, 2, 3, 4, 5. Every 5 is worth 10. So if I go 1, 2, 3, 4, 5, that's 20. 1, 2, 3, 4, 5, that's 30. And then 40 at the end. Alright, so let's see if this makes a little bit nicer graph. This time, every time I move over, I go 2 minutes, which for the second studio, which is 4 for every 1. If I go 2 minutes, that's 8. I kind of want a multiple of 5 up here. So if I go 3 minutes, oops, I'll do that. 3 minutes, that'll give me 12. I might have to go 5 minutes. So if I go 4, I'm going to erase all this in a minute. That's 16, but if I go 5 minutes, that's 20. Oh, done. And that's what I figured out already the last time. Every 5 minutes is worth 20. Alright, so 5 minutes, I kind of have to go in between, but that's okay. That's halfway. That's right here. So every 5 minutes, starting at 20, go over 5, and up another 20. It's kind of a weird way of doing it, but the next one will meet at a real line. So at, oh, and that's not 5, that's 7. 5 minutes is at 20 right here. And at 10 minutes, it's another 20. Helps when I write my lines on the actual line. Here we go. Alright, I zipped ahead a couple points there. And there's my line. It does keep continuing. And then we're going to do the green line. Hopefully this will go smoothly as well. I'm going to go every 5 minutes again, and we said every 5 minutes was $10. So starting at 50, 5 minutes will meet up with this dot right there. Every 5 minutes is another 10. And then 10, it meets there again. This is 10. So it looks like this. And this one can go one more than the other one could. Right there. That takes up a bit more of the graph and is a little nicer. So let's get back to the question. It says, for what numbers of minutes would each studio make sense? Well, remember, wherever we are on the line, this is the cost. So if I want to look right there, if I took 9 minutes for some reason, well, somewhere in there, 8 or 9 minutes, I look to the left to see how much it would cost. So this is the lowest line that's going to be your best bet. So this part right here, so for part of it, it's the orange line that costs less. For part of it, it's the green line that costs less, and it depends on how many minutes you're going to be there. This is the turning point where it changes. It's changes which studio is better. At first, for a while, the orange studio, or the number 2 studio, that was it Swifty wants, is going to be better. Up until, it looks like 15 minutes. So, at 15 minutes, they cost the same. But before 15 minutes, if it's less than 15 minutes, that would be Studio 2. If it's more than 15 minutes, we'll say less, more, Studio 1 is less. And this is, you can make a more informed decision, or at least these famous people can make a more informed decision. They might both look at each other and say, oh yeah, we're going to take many hours, not just 15 minutes, so yeah, we'll go with Studio 1. And that's how contextual word problems work. We got one more example before we finish this one up. Alright, here's the next one. It's set up slightly differently. This one is, Jason is buying wings and hot dogs for a party. One package of wings costs $7. So we might want to write that down. Wings, $7. And then hot dogs are $4 a pound. And he must spend less than $40. Okay. So we need a little equation here to say that he can't go over. We need to say that somehow. And we don't know how many packages of wings, we don't know how many pounds of hot dogs he's buying. So those are the two things that we don't know. And it really doesn't matter which one you make which. We'll say X is the wings and Y is the hot dogs. Oops. And it's the number of both. So that means if you buy X packages of wings, they cost $7 each, so that's 7X. And I'm going to add that to the Y pounds of hot dogs that cost $4 each. So that's what he'll end up spending right there. We just don't know how much of each he's going to get. But we do know that he wants to spend less than 40. So this sum, this total, has to be less than 40, and that's why this one's an inequality question. And before we move, actually we can graph this one first. So we know that we cannot solve, or we cannot graph something that's not solved for y. So that's our first task, is to just monkey around here to get this to be y is less than, instead of what we had. Alright, we divide by 4, and that's okay that that's not going to work out nice. We got y is less than negative 7/4, just leave it like that, x plus 10. So we need to start at 10, and then it goes down from there, as I have a negative slope. So that means I don't really want to, well actually it also means y, since this is going to be my y, this is going to represent the hot dogs on the left side. Get that straight first. And that my x is going to represent wings down here at the bottom. I want 10 to be, I think, my highest. I think that's what I want. So if I start way up here at 10, I can go by 1s every 2. Like that. Might be a little overkill. I don't need to use quite all of my graph, but I think it'll be good. And this equation makes sense, or this inequality makes sense, because let's say I bought 0 wings. It's a pretty lame party if he wants wings and he's buying 0 wings, but we say y is less than 10, which makes sense because 10 pounds of hot dog would be exactly $40. And that actually wouldn't work because he has to spend less than 40, but that's why we're going to make a dotted line. But either way, the math kind of works out. All right, so we're going to start here up at 10. And we're going to go down 7, right 4. And now when we say down 7, we don't mean down 7 blocks. We mean down 7 units, which is actually down to the 3. And then right 4. But we haven't decided what our wings, what that scale will be. So we have to figure that out too. Doing a quick what-if scenario, I can see that wings cost even more. So he can't really... Oh, look, email. We are getting no more than, well, we can't even get 6 packages of wings, because if we bought 6 packages of wings, or Jason bought it, it'd be $42, and that's more than he has. So I don't even need to go up to 6. I just really need to go up to 5, or maybe 6 just in case. So I can probably do the same scale. I could even go by 3s. Let's see what happens when I do that. 1, 2, 3, 4, 5, perfect. 6. I didn't plan that either. Okay, now when we go down 7, right 4, we know exactly how much we're going. Down 7, right all the way over here. So working with small numbers, that's what happens. And we can't even put another dot in. Are we going to head to that? Oh, that was pretty good. Alright, so there's my dotted line that represents the not spending over 40. You can take anything under this line because it's y less than, so I'm going to shade like this. Like that. And anything in there works. Any coordinate in there would be the correct number of wings and hot dogs to satisfy the need to spend less than $40. But we still have a whole other equation left, which is, so let's see, it's in this part. Jason knows that he will be buying at least 5 pounds of hot dogs. Write an equation, or inequality, to represent this situation. Well, that's a much simpler equation. Excuse me, I keep saying that, inequality, because it only has to do with hot dogs. So we say y, which is the number of hot dogs, has to be at least 5. That means it's more than or equal to 5. Hopefully that made sense. That's the at least part, would be that symbol. So we go up to 5 for hot dogs. And this is just a straight line across. We want any coordinate that will be a y value greater than 5. So we just draw a straight line through like this and shade above it. And we have this little triangle area that satisfies both scenarios of at least 5 hot dogs and that it costs less than $40. So the last thing it says is identify 2 solutions and justify your answers. So we're going to do that. We're going to pick a scenario here. Maybe right here and right here. Why not? Just randomly pick those. Actually, no, I don't want to pick those because I chose something that's not exactly one. So here, not this one. And yeah, why not this one? So the first one is 1, 6. The other one is 1. Oh, I picked up decimal for that one too. I'm pretty good at this. 1, 8. So I write my equations out, my original one. And my other original one. And I check. So 7 times 1 plus 4 times 6 is less than 40. And I get 7 plus 24 is less than 40, which is 31 is less than 40. That one works. And then, of course, the y is going to work because 6 is greater than or equal to 5. So that works too. And I'm going to be done before 20 minutes hits. Good luck. I'll see you tomorrow.